Okay, so we are now going to start with the method of joints, where we have broken this truss up into the 4 different joints, and we've drawn free body diagrams at each of the joints. So I've got joint A, joint B, joint C, and joint D. And we need to determine exactly what these forces that are acting on each of these joints are. So first off, we're going to start with the simplest one to solve, which will probably in this case be joint A. So I'll come back over here and I will redraw joint A. And as I do this, this is going to be vector AB. This is vector AD. So we've got A and the Y here, which we know is 194.44 pounds. So, and we already determined, of course, that with this being a pin, that we had the force at A, or the reactionary force at A and the X, which was 0. So we really don't necessarily need it, but at this point, but you might want to keep it in there just to help you reference where these two forces came from. Now, once we get into our joint and our method of joints, we're going to put everything here in terms of X and Y, and we're going to go back to our static equilibrium equations to solve for anything in the X and anything in the Y. So with us having this arm or this vector here on this joint AB, that angle makes it hard to us. So we got to break that down into its components. And if we break this down, the components here, we now also have AB in the Y and AB in the X, so that we can use these. Now, as you recall, we're going to need to replace these with some form of AB. So sine of theta here is the opposite ABX over the hypotenuse AB, which means ABX, this magnitude here, is going to be AB sine of theta, whatever theta is going to be. In this case, we know it's 45 degrees. Cosine of theta will be ABY, or the adjacent over the hypotenuse, which means that ABY will equal AB cosine of theta. So ABY here is the same as AB cosine of theta. ABX here is the same thing as AB sine of theta. So let's line up and consider what are our forces in the X on joint A. And we see here that we got vector AD, and that's going in the positive direction. We've got ABX, that too is going in the positive direction. We got A into Y, which is 0, but that was going in the positive direction as well. So we got these three here. And we also have the forces in the Y on joint A. And we have AY, and that force vector is going up. We got ABY, that force vector is going up. And that's it with those two. Alright, so at this point you can really kind of decide which one that you want to solve for. So when we go back here to our static, sum of the forces and the x are going to equal 0, which will equal AD plus ABX plus AY. Now we already determined our AX here. We already determined that AX is 0, so we can eliminate that. And AD, we don't know yet. And ABX, we're going to replace with this, because we know ABX equals AB sine of theta, so that we can get this. So here, 0 equals AD plus AB sine of theta, or 45 degrees here. So minus AD equals AB sine of 45 degrees. Now, we could go ahead and put sine of 45 degrees in its numeric value at this point, but we'll just leave it for that. I don't have anything for AB, and I don't have any value assigned for AD, so I'm kind of at a stop right here. Let's go into forces on the Y joint. So as we sum the forces in the Y, they're going to be equal to 0, which will equal AY plus ABY. And again, we will substitute. 0 equals, notice our AY value is 194.44 plus the ABY, which we've determined up here to be AB cosine of theta, which is 45 degrees. So now, as we subtract both of these out, so we get minus 194.44 equals AB cosine of 45 degrees. AB equals minus 194.44 divided by the cosine of 45 degrees. So AB again, now we'll get our calculator, 194.44 divided by cosine of 45 equals 275 pounds. We'll just round up for now. So 275 pounds is AB. At this point, we can go back up here to our free body diagram, and we now know that this is 275 pounds. And it's actually a negative 275 pounds. So because of that value, that tells us our original assumption on direction here was wrong, and that this is actually going this way. So, and instead of having tension on there, we're actually putting that under compression. So and this joint here is under compression. So, and that is acting that way. So now that we have AB and we have a minus, we can go back in and replace this right here with it. So minus AD equals minus 275 times the sine of 45 degrees. So 275 minus times the sine of 45 degrees equals a minus 194, which means that AD equals 194, positive 194. So AD here, again, replace that. It is being pulled, that is in tension, so this is 194 pounds. Now, notice here we have joint A, and we've just figured out it's got 194.4 pounds acting on it, 275 pounds on AB. So take a look, and we'll decide now here on which of these to do next, and we will work on joint C going forward.